Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. In this video, you're going to see some basic ideas about angles, how they are formed, and what are the different types of angles. So let's see, we have two lines overlapping with each other, AB and AC. If I move AC away from AB like this, you can see that the angle being formed between AB and AC. The green area between AB and AC is called the angle between AB and AC, which is also written as BAC or CAB. You can see that AC can be moved all the way around until AC comes back to the original position overlapping AB. And in this case, we say that the angle formed is a complete angle. The green angle here is called a complete angle. If the line AC is kept in such a way that AC is vertical line and AB is a horizontal line, in which case we call them to be perpendicular to each other. In this case, we say that the angle formed in between AB and AC is a right angle. But if this angle between AB and AC is less than the right angle, that is between 0 and the right angle, we say that the angle is an acute angle. For example, in this position, the angle formed is an acute angle. I can move the angle away from right angle and make it into a straight line so that CAB makes a straight line. And in that case, it is called a straight angle. And the angle in between the right angle and the straight angle is called an obtuse angle. So in this case, if I keep AC in this position, the angle formed is an obtuse angle. So the obtuse angle starts just above right angle. Say this is more than right angle, therefore this is obtuse, until it reaches the straight angle. Any angle between right angle and straight angle is called an obtuse angle. If I proceed further, the angle formed after the straight angle until the complete angle is called a reflex angle. So anywhere in this position, you can see that the angle formed is a reflex angle. So if we start with a 0 angle, acute angle makes into a right angle. It's a right angle at this position when AC is perpendicular to AB, and we move further to make obtuse angle. Anywhere after the right angle, it is an obtuse angle until it gets into a straight angle. This is a straight angle here. And if we move further, we get reflex angle all the way until we get a complete angle. So this is an acute angle. It's not necessary you have to just move AC alone. You can also move AB to make the angle. So we are making different angles by changing AB now. So this is an acute angle. This is a right angle with AB and AC. This is an obtuse angle, and this is straight angle. And we can go further to make reflex angle if I move AB still away from AC, and you can see that reflex angles are being formed until I get a complete angle in this way. And in this case, if I keep AB at this position, you can see there is a reflex angle in green, whereas on the other side between AB and AC, which is not marked, you can see that there is an obtuse angle formed. On the either side, you can see one angle is reflex and the other angle is obtuse. But in this case, you can see that one angle is reflex. The green one shown here is a reflex angle, whereas the one part that is not shown is an acute angle. And both together will make a complete angle. But if I make a straight angle with AB and AC, the other side of the angle is also a straight angle. Therefore, you are having a pair of straight angles in this case. But when I have an acute angle between AB and AC, the other part of AB and AC makes a reflex angle. You should also notice that it is the position of AC with respect to AB that changes the angle size, not the lengths of the AB or AC. Now let's see some angles around us. You can see a nice park here, and you can actually find out a lot of angles in this place. Say for example, if I consider the angle between these two branches, you can see that you have an acute angle between these two branches. Whereas if I take the angle between the trunk and this branch, you can see that there is an obtuse angle between them. And if I take the angle between these two branches, there is an acute angle formed between them. Let's consider this picture and see how many angles we can identify. Let's take these two sides of the roof, and the angle between them is an obtuse angle. And if I take the angle between the sides of the door, it is a right angle. And the angle formed between these two parts of the figure, it's an obtuse angle. If I draw a line at this position and another line at this position, the angle, if I consider on this side of the two lines, I can see that there is a reflex angle being formed there. And I can actually find more and more angles in this picture. And this is a beautiful picture. You can have a lot of angles between any two lines. Say for example, I take this line, and you can see that the angle formed in between them is an acute angle. If I take this line and this line, the angle formed in between them on the other side is a reflex angle, while on the inner side it's an obtuse angle. I can consider these two parts of the picture, and I can say that this angle is an acute angle. And you can say that you can also find other angles in the picture, like here and here, which gives you a right angle, and etc etc. You can actually identify lots of angles in this picture. Whenever you walk outside again, find out how many angles you can identify. Thanks for watching. Find out more about angles in Ganitika.com under Angles chapter. Bye bye. Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. In this video, you will learn about units that are used to measure angles, and you will also learn how to measure and construct different types of angles. Let's start first by cutting a circle into equal parts like this. Since the parts are all equal, the angles inside them are also equal. But if I continue cutting this into smaller and smaller parts, the angle inside them becomes smaller, but still they are equal to each other. I can continue cutting the circle until I get 360 equal parts. So the angle made by these parts is named as 1 degree. So when a circle is cut into 360 equal parts, the angle made by one part is called a degree. So degree is a unit to measure the angles. So in a circle, we have 360 degrees. You have learned that a full circle makes a complete angle. Therefore, a complete angle is actually equal to 360 degrees. And it is written as 360 with a small circle on the top. The small circle on the top of the number indicates we are measuring the angle in terms of degrees. We can also measure angles in another unit. Instead of cutting the circle into 360 equal parts, I am going to cut it in a different way. So I measure the radius, and for the same measurement, I cut an arc on the circumference of the circle. So in this figure, the length of the blue line and the green arc are the same. I complete the part of the circle by drawing this radius. So in this figure, the blue line, the red line are radii, therefore they are equal. Since we have measured the green arc to be equal to the radius, all the three colored parts are all equal to each other. The angle made by this part of the circle is called a radian. In fact, 1 radian is approximately equal to 57 degrees. So, radians and degrees are two of the units that are used to measure angles. I can continue cutting the circle in the same way, where the arc's length is equal to the radius of the circle. So, I am getting third part on the circle, the fourth part, fifth part, and the sixth part, and I am left over with a small part in the circle. Which means I have so far constructed 6 radians inside a circle with a small leftover. The leftover part has approximately 0.2 radians. Therefore, in total, a circle has 6.2 radians. Previously, we saw a circle has 360 degrees. Therefore, 360 degrees is approximately equal to 6.2 radians. In fact, 360 degrees is equal to 2 pi radians, where pi is the irrational number. More about radians can be seen in the topic trigonometry in the website Ganitika.com. In this video, we will only be dealing with degrees. Let's summarize what we just learned. We learned 2 units for angles. In fact, there are more units that are used to measure angles, but in this case we just saw 2 of them, degrees and radians. Degrees are written with a small circle on the top of the number. So 35 degrees is written like this, whereas for radians we don't write any units. We just write the number of the measure for radians and we don't write any units for radians. In one full circle, when it is measured in degrees, we have 360 degrees. When measured in radians, we have 2 pi radians. You can notice that after 2 pi, we don't write any units or any symbols to represent radians. So if we write 2 pi, you know that we have measured the angle in terms of radians. Let's continue to see how to measure angles. The instrument used to measure angles is called a protractor, and it looks like this. Each division in the protractor is 1 degree. Therefore, a protractor measures the angle in terms of degrees. You should have noticed that the protractor has the numbers ranging from 0 all the way to 180 degrees on this side, as well as 0 to 180 degrees on this side. This is helpful to measure angles on both the sides of the protractor. And another thing you can take from here is a protractor can measure maximum of 180 degrees in this case. There are also circular protractors which measure 360 degrees, but this protractor measures up to 180 degrees on both the ways. The center of the protractor should be aligned with the vertex of the angle like this. So the vertex of the angle should be coinciding with the center of the protractor, and the base line should coincide with the 0 of the protractor. Once you look at the 0, you should start measuring the angle from that part of the protractor, in this case the inner part of the protractor. So from 0, 10, 20, 30, 40 up to the second line. In this case it measures 50 degrees. Therefore, the angle measured in this case is 50 degrees. If the angle is given on this side, align the protractor with the vertex of the angle and the base with the 0 of the protractor on this side. Therefore, the 0 is on the outer side of the protractor. So carefully measure the angle from 0, 10, 20, 30 all the way to the second line. In this case, the second line meets the protractor at 40 degrees. Therefore, the angle measured here is 40 degrees. Let's measure this angle using the protractor. Take the protractor, align the center of the protractor with the vertex of the angle and the baseline with the 0 of the angle. Now you should understand which side of the protractor you should measure. This is on the outer side. Therefore, measure from 0, 10, 20, 30, 40, 50 all the way up to the second line. Here the second line reaches the protractor at 60 degrees. Therefore, the measure of the angle here is 60 degrees. Another example, align the protractor accordingly and check for the baseline coinciding with the 0 of the protractor. It goes on this side until the second line. It is 140 degrees. Therefore, the angle made by this is 140 degrees. Let's see how to construct different types of angles. In the previous video, you saw all the types of angles, namely acute angle, right angle, obtuse angle, straight angle, and complete and reflex angles. In this video, you will be seeing how to construct these angles. Let's start by constructing a 40-degree angle. First, you need the baseline for the angle. Therefore, you draw the baseline of any measure. Next, we need the vertex of the angle. So, mark the vertex on one side of the line that you just drew. Put the protractor on the vertex so that it aligns with the baseline and look for the 0 on the protractor. Now, we are asked to construct 40 degrees. So, from the 0, measure up to 40 degrees. The 40 degrees is here. Mark the point on the 40 degrees and then join the vertex and this point marked. Therefore, we have constructed 40 degrees now. From the baseline all the way up to the green line, it is 40 degrees according to the protractor. And we just constructed an acute angle. Now, let's construct 90 degrees and see what angle is it. Make the baseline of any measure. Mark the vertex. Align the protractor on the vertex and the baseline. Look for the 0. From 0, count 90 degrees and it stops here. Mark at 90. Join the vertex and the marked point. and therefore the angle that you have made is 90 degrees. You can see that the green line is vertical and the blue line is horizontal, and they both are perpendicular to each other, which means we have just constructed a right angle. 90 degrees is a right angle. Let's construct 120 degrees. Make the baseline, mark the vertex, align the protractor accordingly, look for the 0, and from 0 go on up to 120 on the protractor. Mark the point at 120, join the vertex and the point. Now you have constructed 120 degrees, and looking at the angle, you know it is an obtuse angle. How to construct 180 degrees? Construct the baseline first, let it be a little longer, and let the vertex be placed in the center of the line. Place the protractor accordingly. Look for the 0 on the right side or on the left side, but we usually start with the right side. So look for the 0 and go all the way up to 180 degrees, which means you are going to the next side of the protractor. So as I said in the beginning, a protractor can measure up to 180 degrees. Therefore, from 0 all the way to 180 degrees, we have a straight angle. So this is 180 degrees, which means a straight angle measures 180 degrees. Let's now construct 220 degrees. 220 degrees is more than 180 degrees. Therefore, we will first draw 180 degrees as we just did before. This is 180 degrees. Now we need little more than 180 degrees to reach to 220 degrees. Therefore, keep the protractor on the other side of the line. Let's find out how much more we need to draw now. Subtracting from 220 degrees, we get 40. So we need 40 more degrees to reach up to 220 degrees. Marking it and joining the point. This is 180 degrees plus 40 degrees, making it together into 220 degrees. So this is a reflex angle. Let's construct 315 degrees now. In the same way, construct the baseline, mark the vertex. As you constructed 220 degrees, we can construct it in the same way, measuring what is left over after 180 degrees by subtracting from 315, and we are left over with 135 degrees. Therefore, from 0 all the way to 135 degrees, you can mark a point here and make the angle. Instead, you can subtract 360 minus 315 and get the angle 45 degrees, keeping the protractor downwards. Look for the 0 here and go up to 45 degrees from this side of the protractor. Mark the point, which will be the same point as you marked before. Complete the angle. So you have actually marked the other side of the angle, which is 45 degrees here. Therefore, 360 degrees minus 45 degrees will give you 315 degrees. This is another way of constructing a reflex angle. So this method is by constructing the acute angle on the opposite side of the reflex angle. Thanks for watching. For further learning about angles, visit Angles chapter in Ganitika.com. Thank you. Bye-bye. Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. In this video, you are going to learn about interior and exterior angles of polygons. What is a polygon? A polygon is a closed shape with straight lines as its sides. For example, this is a closed shape with 3 sides. You can see that the sides are made up of straight lines and there are 3 such sides. Therefore, this is called a triangle. A closed shape with 4 sides is called a quadrilateral. A closed shape with 5 sides is called a pentagon. And the one with 6 sides is called a hexagon, and so on. A polygon with 7 sides will be called a septagon, and with 8 sides it's called an octagon. In general, a closed shape with n sides is called a n-sided polygon or a polygon of n sides. The angles inside the polygons are called interior angles, and we are going to discuss about this soon. Whereas in each of these polygon, if I extend one of the sides and make the angle with their adjacent sides like this, extend the sides and make the angle with their adjacent sides, and these angles are called exterior angles. We are also going to discuss about exterior angles soon in this video. First, let us discuss about angles in a triangle, which is the smallest polygon possible. A triangle is made up of three sides as shown here. Let's say A, B, C is a triangle. A is a vertex, B is another vertex, C is the third vertex. We have three vertices and three sides for a triangle. Let me extend this side AB and make a parallel line to AB through the vertex C. You already learnt about parallel lines and transversal lines. If you have not, please visit ganitika.com. Under the chapter angles, you can learn about transversal, parallel lines and the angles between parallel lines. And now you have two parallel lines and the line AC is the transversal. Therefore, the two angles here shown are interior alternate angles. Therefore, they are equal to each other. We can also say that the angles shown here are formed through the transversal BC between the two parallel lines. Therefore, the blue angles marked here are also interior alternate angles and therefore they are also equal. So, if I go back and see the figure, I have two equal angles in red color and two equal angles in blue color. If you see the angles around C, I have three angles there, a blue, a green and a red. And if I add them all, I get a straight angle, and we just learned in our previous video, a straight angle is 180 degrees. Therefore, I have the blue angle plus the green angle plus the red angle around C to be equal to 180 degrees. But alternatively, I can have the blue angle, red angle and the green angle within the triangle also. Therefore, the angles within the triangle add up to 180 degrees. Therefore, sum of the interior angles in a triangle is 180 degrees. Let's consider interior angles of other polygons. This is a quadrilateral. A quadrilateral has four sides. I can cut a quadrilateral into two triangles like this. And in each triangle, the interior angles add up to 180 degrees. So, there are two triangles, each of them adding up to 180 degrees. So, if I add all the angles of the quadrilateral, I will be adding these to 180 degrees, so that I am going to get in total 360 degrees. So, in a quadrilateral, the sum of the interior angles is 360 degrees because I have two triangles inside a quadrilateral, and therefore, each triangle giving you 180 degrees in total. A quadrilateral will give you 2 times 180 degrees, which is 360 degrees. Let's consider a pentagon and see how many triangles we can cut a pentagon into. You can see there are 3 triangles. Therefore, there are 3 180 degrees, and therefore the total sum of interior angles in a pentagon will be 3 times 180 degrees. We have to add up all the angles of the triangle so that we can get all the interior angles of the pentagon. In a similar way, for hexagon, you can cut it into 4 triangles. Each triangle's angles add up to 180 degrees, and therefore the total sum of the interior angles of a hexagon is 4 times 180 degrees. Let's sum up. Sum of the interior angles of a triangle which has 3 sides is 180 degrees, whereas the sum of the interior angles of a quadrilateral which has 4 sides is 2 times 180 degrees because you had 2 triangles formed inside a quadrilateral. Inside a pentagon which has 5 sides, you were able to form 3 triangles. Therefore, the sum of interior angles of a pentagon is 3 times 180 degrees. For a hexagon, 6-sided figure, you had 4 triangles, therefore the sum of interior angles is 4 times 180 degrees, and so on. If I continue like this, let's see how many triangles we can have in a septagon so that I can multiply so many triangles with 180 degrees to get the sum of the interior angles. If you see the pattern, I have 3 sides, 4 sides, 5 sides and 6 sides, whereas the numbers which are multiplied by 180 degrees is 1, 2, 3, 4, which means 3 sides minus 2 gives you 1, 4 sides minus 2 gives you 2, 5 minus 2 gives you 3 and 6 sides had 4, which is 6 minus 2, 4. Therefore, if you subtract 2 from the number of sides, you get the number of triangles. Therefore, 7 minus 2 will give you the number of triangles in a septagon. Therefore, the number to be multiplied with 180 degrees is 5. Therefore, sum of the interior angles of a septagon is 5 times 180 degrees. If I continue like this, what will be the number of triangles for n-sided polygon? You simply have to subtract 2 from n to get the number of triangles and multiply by 180 degrees. Therefore, the sum of interior angles of an n-sided polygon will be n minus 2. N is a number of sides, n minus 2 times 180 degrees. This can be taken as a formula for sum of interior angles of a polygon of n sides. Let's proceed with exterior angles of a polygon. As usual, let's start with the triangle. And this triangle is ABC as usual. We need an exterior angle of the triangle, so I extend the base BC and make this angle and call it as angle 1, which is the exterior angle of the triangle ABC. Let me call this as angle 2, which is one of the 3 angles of the triangle ABC. Now in total, angle 1 plus angle 2 is 180 degrees because it makes a straight angle. Therefore, angle 1 plus angle 2 is 180 degrees. We also saw that the sum of the interior angles of a triangle is 180 degrees. Therefore, if I call this angle as 3 and 4, I can say that angle 2 plus angle 3 plus angle 4 is equal to 180 degrees. Look at these two statements. Angle 1 and angle 3 plus 4 added to angle 2 gives you the same value, 180 degrees. Therefore, cancelling angle 2 and 180 degrees, we can say that angle 1 is equal to angle 3 plus angle 4. Which means if you look at the diagram, angle 1 is here, angle 3 and angle 4 are here. So, the exterior angle 1 is equal to sum of the interior angles 3 plus 4. So, in a triangle, exterior angle is equal to the sum of the interior opposite angles. Angle 3 and angle 4 are interior opposite angle to angle 1. So, angle 1 is equal to angle 3 plus angle 4. Let's consider a polygon of n sides. Let's consider this polygon as a regular polygon. A regular polygon is one where the sides are equal and therefore the interior angles are also equal. We know that the sum of interior angles of a polygon is n minus 2 times 180 degrees. Since this is a regular polygon, this can be divided by n to get one interior angle. Because there are n sides, dividing the sum of the interior angles by n, you will get the value for one interior angle. Therefore, the formula to find one interior angle of a regular polygon is n minus 2 times 180 degrees divided by n. What about the exterior angles? You can see that angle 1 is an exterior angle and angle 2 is its interior angle. So, angle 1 plus angle 2 will be equal to 180 degrees because it's a straight angle. Therefore, we can make angle 1 as being equal to 180 minus angle 2. Also, angle 2 is an interior angle. Therefore, this is equal to n minus 2 times 180 degrees by n, which is the formula just given. Comparing these two, angle 1 can be written as 180 minus n minus 2 over n times 180 degrees. Simplifying this, you will get angle 1 is equal to 360 degrees over n. Therefore, exterior angle is equal to 360 degrees divided by the number of sides of the polygon, and in this case the polygon should be a regular polygon. Let's sum up what we studied just now. First thing we learnt was sum of interior angles in a triangle is 180 degrees, which means if you have a triangle like this, add the angles inside the triangles, you will get 180 degrees whatever the size of the triangle is. The sum of all the 3 angles inside a triangle is always equal to 180 degrees. The exterior angle of a triangle is equal to the sum of the interior opposite angles, which means if we have a triangle and if I call this as an exterior angle, it's equal to the sum of the interior opposite angles in a triangle. Sum of interior angles of n-sided polygon, this could be any polygon, it need not be regular. For any polygon, if there are n sides, the sum of interior angles is equal to n minus 2 times 180 degrees. One interior angle of a regular polygon, it has to be regular polygon only, is equal to n minus 2 divided by n times 180 degrees. Also, exterior angle of again a regular polygon is equal to 360 degrees divided by n, which means the total sum of exterior angles of a regular polygon is 360 degrees. Thanks for watching. To learn more about angles, visit ganitika.com and read the chapter Angles. Bye bye.